Hi everyone, welcome. This is David Pike, the Connector Geek. Welcome back to our latest in the series of Ask the Expert videos. And in fact, this is a somewhat special edition of Ask the Expert because we have our first returning guest. I'm joined today by Jeff Barnes of Molex, who we talked about industrial automation connectors last time. Jeff, great to see you again.
Thanks, David. Really pleased to be here. Looking forward to it. So, thanks for the invite back. Must have done a good job in the first place.
Well, no, it's absolutely, and it was clearly interesting enough that we want to do it all over again. Last time we did speak specifically. Last time we specifically spoke about connectors for industrial automation and some of the challenges that industrial automation faces in the factory environment, which isn't particularly a friendly environment. It's not very easy on electronics. And we talked about how Brad connectors were providing solutions for designers and installers. This time, we want to go into a little bit more depth about the Brad range and talk a little bit about the brand itself and some of the solutions it's been providing for engineers for a long time. And then maybe one or two things that are coming along, because Brad isn't staying still. It's always developing new products. So we want to talk about Brad. The first thing to do is to ask about the Brad name itself. Brad is now part of Molex, but it's a name with quite a rich history and quite an established reputation, isn't it?
Yes, David. I mean, Brad has been around for years. It used to be a bit like a Hoover. It always used to be, I need a Brad lead. And that's because back in the late 60s, the company as was, Woodhead, before Molex acquired them, they developed the first plug-and-play solution for the automotive industry. So this was the largest 7/16 connector. We call it the mini change, but it's the 7/16. And it's been a standard for years, and that was because the automotive industry, the line builders, General Motors, those type of people, they needed something that was quick and efficient to replace if it gets damaged because of welding or cutting or whatever. So then it developed forwards into miniaturization, and that's where we could bring in the M12. So we've been synonymous with quality, with industrial connectivity for a very long time indeed. And that's really part of the message I think I want to bring today is Brad is back, right? So, well, Brad never actually went. Molex acquired Woodhead, and there was a few issues, and some of the people watching this may remember, oh yeah, Brad, we used to use those, but now we use X because there was a problem with Brad. There was never a problem with Brad. Part of the issue was when Molex acquired Woodhead, there was some understanding of the business that needed to be done as to what the business requirements are. So, yeah, we just want to bring that message back that Brad has always been there. We're synonymous with quality. We test everything. Everything is really good. And we've got some really innovative products. We talked last time about the Ultralock, and that's now become an IEC standard. We talk about the L code power, etc., but probably getting a little ahead of myself on that.
Well, it's great to know that Brad is that name with the reputation, with the established track record of performance. We've talked about industrial automation. We've talked a little bit about automotive. You mentioned that's its origins come in the automotive manufacturing industry. Where else can we find Brad products?
You can find them on commercial vehicles, so agricultural vehicles. You can find them on mining vehicles. You can find them on railways. You can find them on ships, as well as material handling, so large logistics centers, the conveyor systems, machine builders, could be on packaging machines, on robotics. A real wide breadth area, and food and beverage as well. So we're the kind of, if you think of, you need an industrial connector for a machine or a process line or a something that is environmentally secure, that's not going to break down, that's vibration proof, that's IP67 or 69K. Think Brad, think Molex.
That actually brings us back to a conversation we had with Ryan from Molex a few weeks back. We had Ryan from the US on talking specifically about some of the latest technologies in the automotive world. And we were talking a lot about cars. We were talking a lot about family vehicles, things you'd see on the road. But you've mentioned commercial vehicles, mining vehicles. The revolution that's happening in automotive design applies just as much to commercial vehicles as well, doesn't it? We're talking about a lot of sophistication in trucks and tractors and that sort of thing, aren't we? And I'm guessing Brad plays a part in that.
Yeah, absolutely. Some of these industries as well are really specialist. And what we've been able to do with customers is design out any failure points. So where they're having continual, or not continual failures, but failures which are a common occurrence, such as, in a mining, you've got a lot of heavy material, rocks, sharp, could be all sorts of things. Sometimes, with these things, rocks falling off these big trucks. And when I talk about rocks, I'm not talking about pebbles. These are heavy things. They hit onto even a conduit and enveloped cable. It will slice through the cable. Therefore, you've then got a machine that's gone down. It's not producing. It's stuck. We can't do anything with it. So what do we do? So, we can use some specialist cable that we've done, which is Kevlar coated cable. And then you have the overmolding issue. How do we overmold a Kevlar cable, coated cable? What do we do? How do we ensure the security that, when it's in underground a salt mine or something like this, which is highly corrosive, highly bad environment? Do you think the sea is bad? Down to a salt mine. And so we can bring all of that technology together and provide a solution for the customer to ensure that they have less failures. The other thing as well is more and more of these type of environments, whether you think it's tractors or, so agricultural machines, as well as other machines, they have issues where not issues, but they're using GPS, right? So they can map from satellites, underground mining, they set their own sort of node system up. So they have their own automated AGVs, if you like. So you have one guy driving multiple vehicles in a mine. And all of this needs that high-speed 5G connectivity. Right, so we're talking to them about the antennas, and then you've got all the connectivity, running the Ethernet or the network over the machine. And again, that uses Brad. So, we're in a lot of environments in there, commercial vehicles, and another one is industrial Ethernet systems within smart factories. How do you pull the Ethernet around the factory? It's all there. So it's becoming more and more, and I think it's one of those things, if you scratch the surface, then all of a sudden you start seeing it where you hadn't seen it before. And that's what we're very good at, is able to spot those opportunities and bring that quality product through.
I think it's worth mentioning that a lot of these applications, they're all related to the Internet of Things. So whenever we're talking about Internet of Things in less friendly environments, so we talk smart factory, we talk smart agriculture, the mining application I find fascinating because it's such an extreme environment. These are all, as you say, 5G and Internet of Things enabled systems. So it's interesting that Brad is going to be able to provide solutions for many of those applications.
Yeah,
if we look at the connectors themselves, cool. If we look at the connectors themselves, Brad, you mentioned Brad is known for its circular connectors. You mentioned the original 7/16 type connectors, and you've mentioned M12. What are the most popular technologies at the moment that Brad are doing? And are they still making those old 7/16 connectors, or is it all moving forward?
So yeah, we are still making them. Absolutely, they go on large fans for air conditioning systems or for refrigerator systems on top of the supermarkets. You may have seen those. They can be fitted into those. They're fitted in multiple areas, and the reason that they're that size is you're providing power. They are a power connector. And the issue always was, well, how do we miniaturize a power connector? It's great if it's a sensor, it's running, 24 volts up to 48 volts or something like this. It's fine. It's little amps, no problem at all in an M12. Now, when you're trying to bring in, I don't know, 415, 630 volts with 16 amps per pin into an M12, it was, and I say was, quite a challenge. But we've managed to do that as well. And so we can bring now under the L code, which is an IEC standard. So under an M12, there's multiple different codes. It's like a polarization, if you like. A code is the standard. That's your sensor connector. That's the one you're going to see day in, day out. And we make thousands of these. It's bread and butter. But when you're talking about the L code, there we're talking high amps. It's like I think it's like 16 amps, 18 amps per pin. I'd have to verify that. I don't have the information to hand. But there we can start now looking at when you're looking at automation and factory automation, machine automation, how we bring in the sensor connectors. If you remember on our last conversation, we were talking about the harsh IO blocks and the future of the harsh IO blocks, and they had the larger power connectors, right? The new generation of these have M12 power. So there's two things to look at there. One is we've got the miniaturization, so that's really great. We can bring that current down through a smaller connector. You've got less size of a connector to push through a machine or whatever you need to do, looming it all up. You've got a thinner type of cable that can carry the same power rating, so that's all good. So you've got weight saving there as well. Then what do we do with the legacy systems, right? So I'm going to build a new machine and everything's going to be this new L code power system. Great. But I'm now going to connect that machine into a power bus that I've fitted because it's now going to go into a process line. So at the front end, I've got a bottle filler. At the second end, I've got, palletizer or some conveyors. And this area is the packaging machine or something like this. So we now do those converter cables as well. So you can go from the larger miniature change cables down to an L code. So we can plug it in. So we're trying to think of how do we bring this in. You've got T-splitters. So, you can do drops on a system. So you're building up a bus system of power in cable solutions. So you don't have to, hardwire everything. That's the key. We're trying to make it as simple as an easy and in a way de-skilling, because when we were young, when we weren't quite so grey, we've been there wiring up panels, wiring up things, and you're thinking, God, there must be an easier way to do it. I remember as a kid, I know this is going off on a bit of a separate way, but we had lots of trees in our garden, and my job was to go and rake the leaves up once a week. And I remember thinking, why hasn't somebody invented a blimmin' vacuum so I can suck these leaves up? Ping, look at Mr. Dyson. If only I had the nuance to take that idea forwards. But there we are. I didn't. So when you're looking, coming back to the machines, when you're looking at machines, when you're looking at what are the future technologies, how are we wiring these machines? Challenge yourselves. Challenge yourselves and say, just because I've always done it this way, ask yourself, is it the right way? That's the key. That's how you need to look at these things. Us old guys are probably telling the younger apprentices, yes, you need to do that because I had to do that. Well, come on, guys. Let's look at getting the young people coming in, challenging our standard ways and saying there's got to be a better way. And then as soon as you start using this solution, where you're using connectivity in a cable rather than hardwiring everything onto terminals, I don't think you'll ever go back.
It goes back to that plug and play functionality that you mentioned at the start. It gives the flexibility of being able to reorganize, redeploy, and fix things easily. There's a couple of other things I wanted to pick up on that. You mentioned weight. It's very easy for everybody to forget that weight is important, even if we're talking about big commercial vehicles or mining vehicles. With the amount of cabling that's going into these things now, weight is a significant issue, isn't it?
It can be, and if you look at a machine, that it's fixed, it's on the floor, right? There are heavy machines and there are lighter machines. Sometimes you have to have a reinforced floor. Is it going on the first floor? Because when you look at factories, you don't just look at the ground floor. You have mezzanine floors because it goes up and around. You're putting conveyors up into the air and all sorts of things. You're trying to use the cubic meterage rather than just the square meterage of the floor. And when you're talking about weight, maybe there's a way of reducing the loading. So with a conveyor that's running up, it's going to be a certain weight, and you could say, well, actually the cables, it's not going to be, significant. But when you're talking a cable coming from sort of like this diameter to finger diameter, then it can be over a length, right? You pick up a 10-meter mini change cable and a 10-meter M12, the weight difference is immense. And then you can also look at, if you look at the actual machine builder, so that's in service in a smart factory or a factory. It doesn't have to be a smart, fully smart factory. But then you look at the machine builders, and if they're building a significant size machine, right, they've got to palletize it. Okay, it's going to be shipped, whether it's in a container, whether it's under just a pallet and we're just shipping a smaller machine that fits on a pallet, or whether we've got to put it on a truck and we've got to drive it somewhere, or am I doing that? Am I using a freight company to do that? You pay per weight. That's how you pay it. Whether it's in fuel costs because you've got your own truck, or whether you're shipping it in a container, yes, they'll pay by cubic meterage, the size of the container, but they also pay by weight. And so if you look at what's happening in the world recently, I'm talking about the last 6 months. This morning, I was looking at my energy prices going, oh, my word, it's going up again. This is a global thing. And you've got global issues on freight as well, in the ports, in the, in Suez Canal that happened a few months ago now. There's lots of things to consider. And quite often people don't look at the total cost of ownership. They just look at, oh, well, it's only, cable. It's not going to be much. It's like AA batteries in a remote control, right? So now they get delivered with everything. Before, when we were young, David, I'm sure you remember this. I certainly do. You used to get a VCR, there we are, showing our age, and you just get the remote control, you'd open up, there's no batteries. Why? I'm going to have to go and get some batteries, right? These are little things people didn't think about. Now they can add the batteries in, it's not long, it's easy. So coming back to the weight, and I'm sorry, I keep rambling away. Coming back to the weight, if you actually look at, pull out from the coalface, so you look at the wider picture, cables aren't that heavy individually. Add them together, they are, because cables are made of copper, right, with insulation. copper is not the lightest material in the world. So the longer they are, the more power they take, the wider the cross-sectional area, the heavier they are. It's just one of those things, you just need to be aware. And when you're shipping globally, it's incredible. We no longer ship. We do these big cable reels that fit onto cranes. When you see a crane and you have, I don't know, a magnetic thing on it, that's got to be powered, right? So we do these retracting cable reels. So as it goes up, it retracts. When we ship those from America, we don't ship them with cable. They come blank, and then the cable is fitted by our customers, because the shipping cost loaded with cable, unloaded, it just doesn't make us any sense. And the customer go, whoa, that's really expensive. Well, it's because of the shipping. Weight is important.
Yeah. I think that's important for everyone to remember. It doesn't matter the application. Weight is an issue, and it's always worth bearing in mind. The other thing I just wanted to pick up on was we talked about A codes, we talked about L codes. I think it just reinforces the message that the M12 series as a whole is quite ridiculously versatile. There are so many different coding options that do different things. We talked about sensor connectors, we talked about power connectors, but there's also Ethernet connectors in the family and various other applications, all within that M12, and the coding means that you can't plug them in the wrong way. So the M12 could be the most versatile connector in the world, couldn't it?
I think so. I mean, certainly when you just look at just an M12 cable, there's many variants, right? Male, female, just on the A code, it's male, female, straight 90, 3, 4, 5, 8, 12 pole. It's incredible just on those. And then you've got all the variable cable lengths, 0.6, 1 meter, 2 meter, 5 meter, 10 meter, 15 meter, 20 meter, 30. These are all standards, right? These are our RAD standards. And then you have all of the different lengths that maybe we customize. What type of cable is it? Is it PVC? Is it PUR? Is it our WSOR cable, which gives the same benefits as PUR, but price sensitive down to PVC? So there's a stocking benefit as well for companies. There's lots of different variants, and then you've got the coding: A code, B code, D code, P code, T code, S code, X code, L code. It's just it's sometimes ridiculous. And you mentioned Ethernet, and I think it's important to mention here that what we're seeing with the faster and faster data, with the faster and faster data, or the larger data load, we're starting to see a transition from D code, which is Ethernet, which is the standard 4-pin, so 2 twisted pair, into X code. So X code is 4 twisted pair. So there's 8 connectors, and it comes in an X, so there's 2 dots in each one. And we're starting to see a transition now, certainly in technologies where that is moving forwards. That's becoming because of the data rate. It's a bit like, the RJ45s and moving up from those, Cat 5, Cat 6, Cat 7. It's a similar type of thing, we're seeing in factories. And the other thing that's coming through as well is the single pair Ethernet, so SPE. So that will be coming into an M12. It's not there yet, but it will be coming into an M12. There's going to be the IP20 version, so cabinet versions to begin with, but then it's going to be miniaturized. There is a standard that's being produced, if it's not already produced, which we're part of, which is part of the single pair Ethernet revolution. And that's where you're then starting to see, again, why is it coming through? I've got 4-pair Ethernet, I've got 2-pair Ethernet, now I've got single pair Ethernet. Weight. That's the thing. Weight and transmission speed. That's all. That's what is driving those technologies forwards. So we'll have those out hopefully in November. We'll have our first single pair Ethernet, and that will be under Brad. So we're hopefully launching that at the SBS fair in Nuremberg as well. So come and see us and have a talk.
You've mentioned SPE. SPE is something that I've been interested in since it became a thing to talk about. And for those of you who aren't familiar, SPE, single pair Ethernet, it's aimed mainly at the industrial automation market, the factory market, where the devices on the factory floor can now be part of the Ethernet network using SPE connectors. It's to integrate the networks across the whole factory. The SPE standard's actually very interesting, very exciting for installers and for machine builders. But I want to take it a little bit step further back. We talked about Brad, and you talked about the Brad as part of Molex. How does Brad integrate with the rest of the Molex products? I'm thinking, for example, HDC, the heavy duty connector range from Molex. How does Brad tie in with the other Molex offers?
Well, I mean, under the other Molex brands, we like our brand names. We have the MPM, which is the square solenoid DIN connector products. You've got the you mentioned there the HDC products, so the heavy duty connector products. We've got our Flamar cables. We've got some NIC cards under different guises, and then Brad is probably the overarching connector series. So while we have the MPM, it's a DIN valve connector, we can put an M12 on it. That then becomes a Brad cable. HDC, we can come from an HDC into a M12, or we could supersede a competitor's HDC into a Brad circular M12 connector. Because what we do as a company is we will look at what is the best technology available. If we always use the technology that was available at that time, we would be driving steam-powered cars, right? Then came electric cars, battery cars. They were there, electric vehicles. It's a big thing now, but these things have been around over 100 years. It just that there was never really the technology, and that's the battery technology, to be able to take it forwards. Henry Ford, he was the first one. No, he didn't build the first car, but everybody remembers him because he was the first one to build a production line to build the cars. And then, all the way forwards, if we stood still, we'd be using stone. And that's the thing. So when you look at technology, when you look at how do we move forwards, and this is something that we do, is when we go to customers and they say, I want a X, or certainly if I go and see customers and they'll say, Jeff, I want a XYZ. My first question is why? And that may seem quite bold, arrogant, confident. I don't really know. It depends. Obviously, I don't just go, oh, why? But what I'm asking really in that question is, what is your thinking to get you from where you are there to using these products? Because as when I was a sales engineer, when you look at salespeople, there's different types. You have catalog salespeople. Sorry if I'm going to put you in those, and I don't mean RS in this instant, but it's like, I do one of those. I do one of those. They're not looking at what is best for the customer. And then you have those hunters, those opportunists that come in and try to understand. They become the go-to person. Do you have X? Why are you thinking of Y? Because these guys, and I include myself in this area, we see lots of different companies, lots of different customers, whether they're end users or machine builders or system integrators, or all these people that are building these things. And I may see one guy building it one way, and I think, actually, that's a really smart idea. I can take that idea and pass it to the next customer. So I'm always challenging why they're doing it. Certainly if I see connectivity, I look at it and go, well, is that the best solution for what they're doing? Is that the right solution for it? Because sometimes it is what they're doing is the right solution. Is it future proofing? Are they thinking about future proofing? Are they thinking about moving forward into the smart world? Are they thinking about the IIoT? Are they thinking about Industry 4.0? All the same things, just different names. What is the latest technology that they could possibly utilize? And it's not for everyone. Okay, you can talk to them, say, I think this is a really good idea, X, Y, Z, but sometimes they'll go, actually, I'm quite comfortable in doing this because they see the wider picture just for them. Our job is to kind of build on their knowledge, talk to them about what they're doing, how they're doing it, etc. And when you talk about the Brad products, there's so many that we could utilize. Sometimes you can go in there and you can actually just bombard them and go, oh my word, it's just connectors. I don't need it to be this complicated. We can spin that down. We can bring that down to a very simple way just by asking that question, why?
I think that's a really interesting point. That there are instances where customers will need the very latest technology, the very latest innovative solutions. There will be other customers who are aware of, let's say, legacy products, and they need to be backwards compatible as much as we're looking forward. And I think that's one of the strengths of Brad, from what you've mentioned, is that yes, there are the advanced products, there are the new products, but there is also the established, tried and trusted set of solutions that will continue to work. And so it's important that I think customers realise that Brad offers both the established legacy and the cutting edge. And actually, on the subject of cutting edge, we've talked about L code as being the next big thing in terms of power connectors. We've talked a little bit about SPE, single pair Ethernet, as being the next generation of Ethernet connectors. You mentioned earlier Ultralock, and I think there's a new development in the Ultralock family. Can you give us a little bit more information about that?
Yeah, sure. So I think in the last video we talked about Ultralock, and we talked about how useful it is. It's a push-pull connector. It's blind fit. It's IP67/69K, vibration-proof, speed fit. You could call it. There's many different names you could call it. But basically, it takes the M12 standard M12 where you have to thread it on and you screw it on. Right? It takes some time. These ones just click, 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 click. And when you need to replace it, you just grab it and you pull it off. So we've had Ultralock, which was a Molex developed project or product, and that was actually developed for the agricultural industry. We've had it since 2005. It was developed for the agricultural industry because Farmer Joe, in his wisdom, he's got his tractors, his muck spreaders, and he's got his high pressure petrol pressure washer, high temperature, and he's washing down his tractors. And the standard IP67, whilst it's sort of splash proof, it's 1 meter at 30 minutes. If it's submerged, it doesn't stand a high pressure hose, pressure washer. And this is what Farmer Joe was doing. He was washing down his wheels like this, load of muck, and then you see the electrical connector, and like all humans do, we go, oh, electrics, water, and we go and give it a good old squirt in there. Everything started failing. So it was a product that was developed to meet that IP69 standard. You didn't have to worry about when you're threading things, the seal splitting because it's over tightened or it's not been tightened enough, so it's not sealed. You just wanted something that you could click on. So that was in 2005. It's a fantastic connector, I have to say. I mean, I joined in Molex in 2012, first time I'd ever seen it. Right, so it had already been out 7 years when I first saw it. But why aren't we using it? And it was because it was Molex proprietary product, right? It's our product, it's our patent, and that's what, we would be defending our patents left, right, and center if anybody tried to copy it. But what it meant is it didn't become a industry standard. As soon as things don't become industry standards and they're a bit niche, they're a bit unique, you can only buy it from one manufacturer. The device manufacturers don't look at it in a reasonable light, so you can only connect it to things from Molex. So what we did a few years ago now is we formed a group that several other manufacturers of automation connectivity came together, and we've taken the Ultralock and we've taken cost out of it. Okay, so the original Ultralock is all metal. The new Ultralock 2.0 is a plastic housing to reduce the cost, so it becomes more attractive in the M12 world. We've opened it across multiple manufacturers so they can all build it under license. So we've shared some of the patents, or we've changed some stuff, so and that's now become an IEC standard. Boom, across the range. Brilliant. So now we're starting to see device manufacturers start pick up on this. And it's going to be a slow burn to begin with, but then I think it's going to really take off, where this is the revolutionary product that is going to be that update of the M12 that's been around since, when was it? Late 70s, early 80s. I think the M12s came out, maybe even before. Put it in the comments, people. Tell me when it was. But this threaded technology really is I think it's going to disappear, and it's going to be this push-pull technology, because it's the speed. It's giving me everything I need. It's giving me the IP rating guaranteed. It's giving me that solid mechanical connection. It's giving me the solid electrical connection. I can fit it to multiple things. I don't have to cross-thread it. I don't try and jam it in. We're speed. If something goes wrong in a factory, we can just unplug it and plug a new one in. Don't have to worry about trying to fiddle and connect it. So we're de-skilling that area as well, if you like. So the efficiency of the machines becomes better, because if there's a downtime because the sensor cable's broken or whatever, you could just pull it off, click a new one on, done, dusted. Whereas before, it doesn't take a lot of time threading it, and this goes back to the weight. If you look at an Ultralock that goes click, it takes 5-8 seconds to fit a threaded version of the M12. Times that by 100, and then you've got click, 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 times 800 seconds. Times that by 500, 1,000 I/O on a machine. All of a sudden, you're not there for 5 hours connecting everything up, just screwing in M12s, which is still, again, faster than doing terminations. You're now just pushing them in. You make a mistake because you've connected it in the wrong, you just pull it off, put it on, put. So when you look at the scale of the speed, that's where it becomes really interesting. And that's where you're going to get that efficiency in your machines, because whether it's an end user in a factory, smart factory or not smart factory, it doesn't really matter. In a factory, you'll want to get your product out. That's where you make your money, is getting your product through your machines and selling your product, right? So you don't want a machine to stop, because that means it stops your product being produced. So you want something, click, boom, done. When you look at a system integrator or an installer, if you make a mistake, and let's be honest, not every machine is ever connected correctly the first time you get it onto site. There's always a slight cross connection mistake, whatever. If you're using hardwired, if you use the M12 standard, you've got to screw it in. So you've got all that time. So it could take you, a while to screw it all in together. If you've got a quick fit, boom, 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 done. And then when you look at the machine builder,
Mm.
where you build the machine, you take the machine apart because you then take all the metal for painting, then you put it back together again, then you do factory acceptance tests, and you take it all apart again, and you're shipping it. It gets to somewhere, you put it back on, connect it all together, and do the final commissioning on site. Again, think how many times you're unscrewing or screwing in. Boom, 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 boom. So I certainly believe, and this is my belief, that the Ultralock 2.0 is the name we call it from Brad. This product will replace standard threaded connectors in the future. It may take a little while, but to pull through. But I don't believe the generation that is joining now into factory automation. These guys that are just finishing universities or apprenticeships or whatever. When they get to my age, they will never see a threaded M12. Never. It'll all be a push speed fit, guaranteed. And that's something that's from Brad, from Molex. We're the ones that developed that from the beginning. So when you talk about Brad, when you talk about our products, our quality of products, our innovation, we are the market leaders in that innovative product, in bringing it forwards. What do we do? And that comes down from our ethos, if you like. What's in us. We're always challenging ourselves. What can we do to improve people's lives? What can we do to improve our products to improve people's lives? How can we connect our products in a better way? And that's why we create these connections for life.
I think that's a brilliant place to wrap it up. Actually, I'm a big believer in push-pull connectors. You touched upon the repeatability, the fact that because you're not screwing something in, you're not over tightening or under tightening. Every time a push-pull connector is connected, it's done to a specific standard, to a specific protection level, and they are truly. I understand entirely what you're saying. That they're a solution for the future because they cut down on the amount of time, they make it easier for installers, and there are mechanical and physical benefits to go with it. As I say, I think this is a perfect place to wrap it up. To me, what we've seen today reinforces the fact that Brad has this reputation in the industry as being able to provide solutions that last, solutions that people can trust. But on top of that, I think it's important to know that Brad doesn't stay still. Like Jeff said, we don't just sit and drive steam-powered cars. The fact that Brad are taking these established and popular connector series like the M12 and then continually asking the question, how can we make these better? What benefits can we provide to the customer? And we've just talked about one of the results. We've talked about Ultralock 2.0, a push-pull variation of an established screw-locking connector that could well take over from the original. And I think that's one of the key things for Brad. It's a reliable product. It's a reliable brand name. It's a name people trust, but it's also a name people can trust to develop the solutions for the future. RS Components has actually introduced a large number of new products into the range. So the Brad range on RS Components now represents well over 500 part numbers. These solutions that we've been talking about are available from RS, are available now. And as the new solutions come along, the Ultralock 2.0, and in November, we've been talking about the new SPE connector within the M12. That's going to be a bit of a game changer as well. That will take Ethernet connections onto the factory floor, regardless of the conditions they experience. So in terms of seeing what the Brad range can offer you, have a look at the RS Components website now with this new expanded offer. Keep looking at the RS website and you'll see more products being added as they become available. There is tons of information on the RS website, so not just part numbering, but there's drawings, there's 3D models, there's data sheets, all the info that you'll need to be able to design and select with this type of product. And I think the best thing now for me to do is thank Jeff so much for your time. It's been great to speak to you again. This is clearly a product range that you know that you trust and that you trust can provide solutions for customers. So it's been brilliant to have you with us. Thank you, Jeff.
Thank you, David.
No problem at all. And to everybody watching, thank you very much. And we'll look forward to seeing you on the next Ask the Expert video.